Welcome to homework.
This is the answer to Chapter 22, problem number 64 from the Smith Organic Chemistry textbook. And this problem is asking us to draw a stepwise mechanism for this reaction. And essentially, this is an acetal hydrolysis followed by an intramolecular Fischer esterification. This is similar to another problem in this chapter that asks about the synthesis of vitamin C. And so the first step is going to be hydrolysis of this acetal. We'll start with one of the acetal oxygens grabbing a proton from the acidic environment that this reaction is taking place in. And so that oxygen will now have a positive charge on it. This carbon-oxygen bond will break. And so we end up with a carbocation there. Water molecule will attack that carbocation. And we end up with addition of water to the carbocation. Another water molecule will take a proton from that water molecule that has added. And so that will get us to the alcohol there. And now the exact same thing will happen a second time to the other oxygen. So again, this oxygen now has a positive charge. So there we go. And then what will actually happen this time is this oxygen will add down. That bond will break. And then this part here is going to become the acetone. That's a product of this reaction. So that will leave at that point and become the acetone. And that's the end of our acetal hydrolysis, acetal hydrolysis. And so the next part of this mechanism is going to be the intramolecular Fischer esterification. And so that will begin with this carbonyl oxygen becoming protonated. So we'll put a positive charge there. And that's going to make the carbonyl carbon even more electrophilic than it already is. And so that will make it susceptible to attack by this alcohol. The oxygen will act as a nucleophile. So we'll get to this intermediate where the oxygen has a positive charge. A water molecule will take the proton. There we go. So we'll then get to this tetrahedral intermediate. And what will happen next is one of the alcohols will become protonated. So suppose that is a little difficult to see. Oops. Come on. So this will become OH2. There we go. And so what can happen here is this oxygen can attack the tetrahedral carbon. Since this is now an OH2, it can leave. And that's going to give us our carbonyl here, our ester. This oxygen will have a positive charge. Another water molecule will come and take this proton. The electrons will revert to the oxygen. And that is our final lactone product. So again, this is just an acetal hydrolysis followed by an intramolecular Fischer esterification. And the arrows are as I have drawn here. And that is the answer to chapter 22, problem number 64.